Hello, this is Mrs. Pullen for Algebra 2, Lesson 9.01. In this video, I'm going to go over the basic rules of exponents and their applications. So the first rule we're going to go over is what happens when we multiply powers with the same base. So the exponent are the superscripts, in this case m and n, and the base is x. And the rule only applies if the base is the same. And what the rule says is when you're multiplying powers with the same base, keep the base and add the exponents. So if I'm multiplying 5 to the third, 5 to the sixth, my bases are the same, so I keep the base and I add the exponents, and that would be 5 to the ninth. If I'm dividing and I have the same base, I keep the base and subtract the exponents. So 2 to the ninth divided by 2 to the third is 2 to the 9 minus 3, because I'm subtracting the exponents since I have the same base, which is 2 to the 6. And you could just enter that in the calculator, and that would be 64. This I would have to use a calculator myself. Okay. And now when we raise a power to a power, so it's a single power and I'm raising it to an exponent, that rule, you would keep the base and multiply the exponents. So that 3 to the 5th squared is the same thing as 3 to the 5 times 2, or 3 to the 10th. Oftentimes students mix up the multiplication rule with the power rule. Notice that with multiplication, you have two separate powers with the same base, whereas with the power rule, you only have one base. Okay, so let's apply. So the directions for 1 through 6 is that you're supposed to write the expression fully simplified with only positive exponents. So the first thing I would do is multiply the coefficients. The coefficients are -7 times 2. And I'm just going to rearrange my bases with the x. So x cubed and x cubed, and y to the 5th and y to the 1st. So the -7 and 2 are coefficients. They're not powers because the exponent is 1. So this is just -14. -7 times 2 is -14. But x cubed times x cubed, same base. I keep the base and add the exponents. 3 plus 3 is 6. Y to the 5th times y to the 4th, same base, and add the exponents. And that would be your answer. Number 2, we're raising a power to a power. So the -3 is not a base, it's a coefficient. Notice it doesn't have an exponent other than 1. And basically, it's not really called distribution, but the -3, the coefficient, the x to the 4th, and y cubed are all being squared. So it's -3 squared, x to the 4th squared, and y cubed squared. -3 squared is 9. When you square a negative number, it's always positive. And again, we're raising a power to a power, so we multiply the exponents. 4 times 2 is 8, and y cubed times y squared is y to the 6th. And that's the answer to the next problem. The third, we're doing division. So the 12 and the 20 are coefficients, and so I look to see what's in common to both, and we'll divide that out, and we know 4 goes into both. So 12 divided by 4 is 3, and 20 divided by 4 is 5. And now the x's, it's the same base, and there's an invisible 1 with the exponent of the 4x in the denominator. So I would keep the base and subtract the exponents. 8 minus 1 is 7. I keep the base, and there is an invisible 1 with a y, and y to the 1st minus divided by y to the 4th, you would keep the base and subtract the exponents, and that would be 1 minus 4, -3. Now that answer would be fine, except the problem states that we only want positive exponents. And there's a rule that you learned back in middle school, and that's with negative exponents. when you have a negative exponent, you're actually taking the reciprocal of the base. So x, and how do I know when to do it? When the exponent is negative. So I say you flip your base. So just so we see here, this would be 3 to the negative 2, take the reciprocal of 3, and then the exponent becomes positive, and this is 1/9. If the exponent is, if the negative is in the denominator, then when you take the reciprocal, you're flipping it to the numerator, you're taking the reciprocal in the numerator, and the exponent becomes positive. So 1/2 to the negative 3 is the same thing as 2 cubed, or 8. And even though we're not really doing this now, we have to finish up the other problems that we might as well look at this last rule. Anything raised to the power of 0 is 1. So 3 raised to the power of 0 is 1. Okay, so let's go back to problem number 3. So this is 3/5, and we can write x to the 7th as x to the 7th over 1. And now y to the negative 3, from that negative reciprocal rule, that negative exponent rule, we take the reciprocal of y, of the base, and then the exponent becomes positive. We multiply across and we get 3x to the 7th, 5y cubed. Now there are other ways of doing these problems, but I will show you at another point. Okay, let's go on to example 4. So we want to simplify this. And again, you could put the video on hold and try it yourself, but I'm going to continue on. So I typically would simplify the numerator and then denominator and then continue. So for the numerator, I'm multiplying powers with the same base, so I keep the base and add the exponents. 4 plus 3 is 7 over, and then in the denominator, I'm raising a power to a power, so that would be y to the 6. When I'm dividing, you keep the base and subtract the exponents. 7 minus 6 is 1, and we would just write that as y. Problem number 5, even though it looks different, think about the general rule. We're multiplying and we have the same base of y, so we keep the base and we add our exponents. It's helpful to say the rule out loud and to really get comfortable with it. So now I can combine like exponents. So n plus n is 2n, and 2 plus 1 is 3. And so the final answer would be y raised to the 2n plus 3. Number 6, we're taking one base, one power, and raising it to another power. So the rule is keep the base and multiply the exponents. And we're multiplying a binomial times a binomial, so we're double distributing. So 2 times 2 is 4. The outer becomes positive 2 rad 3. Negative rad 3 times 2 is negative 2 rad 3. And negative rad 3 times negative rad 3 is negative rad 9, which is negative 3. And we combine like terms. And our final answer is 3 to the 4 minus 3, which is 1, or just simply 3. Okay. Number 7, they want you, again, to express the fraction in simplest form with only using positive exponents. And again, I typically simplify the numerator and then simplify the denominator, and then I divide. So this would be 3. I'm raising a power to a power of 2, so I keep the base. 5 times 2 is 10, over 12, and w to the 9th. I know 3 goes into both 3 and 12, so 3 divided by 3 is 1, and 12 divided by 3 is 4, so that's 1/4. And then I keep the denominators, I keep the bases and subtract the exponents. 10 minus 9 is 1. And you can either write your answer as 1/4 w, or you can write it as w over 4. Those two mean the same thing, so either answer would be acceptable. We already went over the different rules, so now we're going to apply them. So we're dealing with negative exponents, and we'll read the directions through 8 through 10. We want to write the following expressions without negative exponents and without parentheses. So we're going to, for number 8, we're going to keep the numerator. I can't simplify it any further, so we'll write it as x to the 6. In the denominator, I can keep my base and add the exponents. So negative 2 plus 4 is positive 2. And now I keep the base and I subtract the exponents to get x to the 4th. I'm going to use the same process for 9. I keep the base. Well, I can't multiply across, but I'm going to look at the base of x separately from the base of y. And I know I'm dividing, so I keep the base and I subtract the exponents. And for the y base, I keep the base and subtract the exponents. And as I mentioned before, it's helpful to coach yourself through this or cue yourself. Go over the rules. So I keep the base. Negative 3 minus 4 is negative 7. And here it's y to the negative 4 minus 5 is negative 9. And in this case, they said no negative exponents. So this becomes 1 over x to the 7th, 1 over y to the 9th. And when I multiply across, I get x to the 7th, y to the 9th. Number 10, the negative 2x is a base. It's not an exponent, so you're not flipping the negative 2x from there, but you're flipping it because of the negative 2 exponent here. So I would flip first, and that's negative 2x squared. And that means the negative 2 is being squared and the x is being squared, so you get 1 over 4x squared. And just 2 more problems. So number 8, again, I would simplify the insides first. I know 28 and 8 are both divisible by 4, so that would be 7 over 2. And I have a common base of y, so I keep the base and I subtract the exponents. And I'm going to put it in parentheses cube because I have to deal with that afterwards. So this becomes 7 over 2 y to the 8th, because I'm adding 5 minus 3 is 8. And now I'm cubing it. And then we are having 7 and cubing it, 2 and cubing it, and y to the 8th and cubing it. So if you take your calculator, you can type in 7 cubed, and you get 343. And 2 cubed, you could do it in the calculator, or you'll know pretty soon it's 8. And for the power, you're keeping the base and multiplying the exponents. So you can either leave your answer like this or write it as 343 y to the 24th over 8. Either answer is acceptable. And the last one, again, I'm going to use that same process. I'm going to simplify the insides first. I can't simplify 3/4, but a to the negative 3 divided by a cubed is a to the negative 3 minus 3. I keep the base and subtract the exponents. And for the b variable, I keep the base and subtract the exponents. And I'm putting it in parentheses and squaring it to remember to do that. So that becomes 3/4 a to the negative 6, b to the 5 minus 4 is 9. And now I'm squaring it. And a to the negative 6, I can rewrite. So hold on. This is going to be 3/4. A to the negative 6 is the same as 1 over a to the 6. And b to the 9th is not, you don't take the reciprocal of that. So I write it as b to the 9th over 1 squared. And you multiply across, you get 3b to the 9th, 4a to the 6th, and now we're going to square. So the 3 is squared to get 9. B to the 9th squared is b to the 18th. Don't forget, in the denominator, you're also squaring it. So 4 squared is 16. A to the 6th squared, you keep the base and multiply the exponent. 6 times 2 is 12. And that's the final answer here. I hope this video was helpful, and I will see you tomorrow.